One resolved coding issue cost this OpenHands agent 631,000 tokens, 23 rounds, and a large share of that work was not writing code. It was grep, glob, and file reads repeated until the agent finally found the patch surface. A new paper says a specialized retrieval agent cut that pooled token total by 19%. On the same 96 issues, the stricter reduction was 15%. But here is the contradiction. A weaker retriever increased token use, so the breakthrough is not search first, it is precision first. We tested that mechanism on a real open source repository. Same TileLang snapshot, same Codex coding agent, same path safety bug. One run saw only the issue. One received 5 plausible files. One received the 2 files that actually mattered. Then a blind 7-check grader judged every patch. This is not a CodeGrep reproduction. The model artifacts were not available when we tested, and our shortlist was supplied manually. What the test can measure is the downstream cost of giving the coding agent no map, a noisy map, or a precise map. The expensive part is not the grep command itself. Every result enters the model's context. The agent reads it, compares it, changes its plan, and carries that material into later turns. Repository exploration becomes reasoning, you pay for again and again. CodeGrep splits that job in two. A 14 billion parameter Quen model gets the issue first. It can run grep, glob, and read in parallel for 3 exploration turns. Then it returns a short list of candidate files to a frozen 30 billion parameter OpenHands agent, which still owns the patch. The paper's sharpest example is a Django migration bug. Without a hint, the agent burned 74 actions and 3.2 million tokens, then failed. With 3 candidate files, it opened the right module at action 6, patched 1 file, passed the harness, and finished at 307,000 tokens. But retrieval only helped after it crossed a precision wall. BM25 precision was 0.375, and tokens rose from 631,000 to 763,000. The GNA retriever reached 0.445 and was roughly neutral. CodeGrep reached 0.677 and bought efficiency. Our task was deliberately bounded. TileLang's trace helper accepted a name like .outside.trace.json and could construct a path beyond the export directory. The fix had to preserve ordinary and safe nested names while rejecting absolute paths, parent traversal, and symlink escapes. With only the issue, Codex ran 14 commands, 7 of them searches. It consumed 591,704 input tokens and finished in 192 seconds. The final patch passed all 7 hidden checks. Then we supplied 5 plausible files. Search commands fell from 7 to 4. That looks like a win until you count the bill. The agent read the false positives, ran 16 commands, consumed 707,876 input tokens, and took 233 seconds. The noisy shortlist used 19.6% more input tokens and took 21% longer than no hint at all. Same correct patch. Same 7 of 7 grade. Fewer searches, higher cost. Counting grep calls alone would have delivered the wrong verdict. Finally, we supplied only the 2 files that changed. Codex used 10 commands, 3 searches, and 340,952 input tokens. That is 42.4% below baseline. Uncached input fell 33.6%, and wall time fell 13%. 7 of 7 again. So our small test did not reproduce the paper's percentage, it reproduced its shape. No context is expensive. Noisy context can be worse. Precise context can compress the rollout without changing correctness. The hard product is not a file search box. It is a retriever that knows which plausible files to leave out. There is still an accounting gap. The paper reports downstream OpenHands tokens, but does not clearly add the retrieval model's own inference tokens to that total, and 14 billion parameters is not free. A production system has to meter both lanes before calling the architecture cheaper. The release state matters too. The paper says the model, training pipeline, environment, and harnesses will be released. We could not find an official author repository or model checkpoint on August 9th. The architecture is testable. The promised open package is not yet something viewers can download. For a small, unfamiliar repository, let the full agent search. The coordination overhead may cost more than it saves. For a large repository with known ownership and dependency boundaries, build a precise context packet first. For repeated, expensive autonomous work, a dedicated retrieval agent can earn its own lane. And measure the right things: retrieval tokens, downstream tokens, files opened, commands, time to the first edit, final tests, and total wall time. The next coding agent breakthrough may not be a smarter model. It may be refusing to pay the smartest model to explore every hallway, while never handing it a bad map.